We are decompiling Castlevania Symphony of the Night. This is made up of wires. We've been doing this over the past several weeks, and we're going to continue today. If you want to know more about the Castlevania Symphony of the Night decompilation project, you can go to soten.z.dev. You'll see progress on several of the binaries that have been decompiled. Some are in flight. That's what the progress is about. I think we're going to be looking at RB0 or RB03 again today. NOO is another new one that we can look at as well. Is RB00 or RB03 on here even yet? It's not. We could do that as well. We could add this to the list. So what is RB03? I don't know. Yesterday I said RB03 was related to the Maria cutscene, but it's not. It is a boss, but which boss is it? I don't know. Let's see if we can get any additional information from the wiki. You can get to the wiki by going to the source code link, which will take you to GitHub. You'll find all the code that's been decompiled there. And let's see if there's a page yet for RB03. Oops, not what I want. Oh, unfortunately I'm not signed in. Let me do that. I have been having internet issues lately, so if the stream drops or other things happen along the way, I apologize, and I'll try to get back up as quickly as possible. Oh, this is the Medusa boss. I did spend some time prior to the stream getting a save point set up. Thinking for whatever reason that this was the clock scene or clock room cutscene for Maria, but that's obviously not correct. This is the Medusa boss. I will get this queued up for tomorrow, so we can look at some of these functions and set a debugger there. If there's anything anybody wants to see along the way as we're going through, please let me know, and I will try to address that as much as possible. If you were watching yesterday or caught the upload on YouTube, we were looking at a relatively small function in this overlay. And let me get back to where it was yesterday. I think we were here. So when we left it yesterday, we had basically all of the instructions were matching, but there were some register differences here that were causing issues. I used the PSP version of this function offline and was able to get a match, which effectively took many of those that array access and building the index to that array and broke it out into several different statements. I'm not terribly happy with what this looks like. This doesn't seem like very natural code, but it does work as is. So I think we'll leave it like that, and we can see that this is matching now as well. So I'm going to take this and switch over to a terminal, and we'll find this function. And so when we build with the ASM in place, the build is fine. Oops, I don't want to do that. So I'm going to take this and paste it in, and then we need the few declarations for global variables that are going to come from the context. And when we build this, we get an OK as well. So this does match. We have one function closer in this Medusa boss overlay. Let's... my guess is that, just thinking through how things are named, let's look at the Medusa boss in the wiki. Need to find the right one. I'm trying to remember which, whether or not this is reverse castle or not. Yeah, so this is reverse castle. So the naming's consistent with what we see in other overlays, and our prefix being the reverse castle or anti-castle, BO being boss, and 3 just being the index of this particular boss. So let's go through and look at some of the other functions here and find something else to decompile. And if anybody wants to see anything along the way while we're working through this, chat and do the other things. Let's see if there's any obvious dupes here. We could work a little bit on refactoring this overlay to pull in as much reuse code as possible. So we do have a bunch of code related to the viewport and how entities are created as they enter and leave the viewport. So that might be worth looking at. There's a lot of win there for being able to quickly get matches there. We actually have quite a bit of... it doesn't look like any of the deduplication has been done on this yet. Or we could look at new stuff as well. I'm going to pull up the splat config for this. This being a new one that I've not really spent much time in. Except for what we did yesterday. Yeah, so this is pretty much at the beginning of this import. So we could start doing quite a bit here to start breaking this up. So let's go through and what I like to do when I'm breaking up these to match other overlays is try to find the boundaries for each of the sets of functions that align with other overlays that we have. And that'll allow us to break this up into multiple C files, and from there we can start mapping those to shared code. So looking at the start, so entity unknown ID 12, entity breakable, those are probably reasonable areas to start. There probably are entities in here, and like the one that we worked on yesterday, there's going to be entities in here that don't exist in other overlays. And so really we just need to start finding where those boundaries are between the shared code and the code that's unique for this function, or unique for this overlay. So what I'd like to do, I don't have a lot of screen real estate to make this readable. Normally I'd have like columns all over the place. I am going to open up, I think, the Maria cutscene just to see what's going on there. I'm going to set no wrap, and if this is hard to find or hard to follow in chat, let me know, and I'll do my best here. What I'd like to see is when these C files are being brought in, how much of this looks similar. And so what we see kind of at the beginning is here's entity breakable and entity unknown ID 12. Which of the shared files already have that? So breakable looks like it's already its own thing. So let's see where that is defined here in so I don't want to do a recursive search, and this is going to be in a header file. So this is just in a breakable header file, and I'm going to open that in a new tab. So we have a few prerequisites that we need. We need create entity from current entity defined, replace breakable with item drop alloc entity, as well as the init breakable symbol, and we can find what that symbol is. But then we just have this one function that we need to locate. Hey Orcum, thanks. It was a good break. I mentioned yesterday, but I'll do it again. I did a lot of hiking, spent a lot of time outside, which was a nice change of pace. I live in the American Southwest, and it has been hot, so getting out of the heat was nice as well. So what I'm going to do to start mapping this, I want to make sure that we have, so there's a bunch of things here, animate entity, several of the of these other functions that we need to have. I know initialize entity, that one was mapped. Yeah, family time is good, especially when it's away from all the stress and activities of life. I like the cold morning, and I miss the cold mornings. That little chill when you step outside for the first time is nice. So let's see, what are we gonna do? Let's open the breakable assembly for RBO3, and then we'll find all the symbols that haven't been defined yet, and basically there shouldn't be anything that's D_US or func_US. I used to live in Wisconsin a long time ago, and the winters broke me. I don't know if I could deal with living through a Wisconsin winter again. $70 to $75 in the afternoon is awesome. Yeah, that is awesome. I would love that a lot. Okay, so we only have one split at the moment, which is the US. So all these are relatively easy to find. This is entity breakable, right? Yeah. And I just want to make sure that we have, like func_ doesn't exist, and D_. We do have a few of those. So we need to figure out what those are and make sure that they are mapped. This A5A0 offset here looks like it's going to be breakable animations. The D_ without a US are have already been defined, so we don't have to worry about those. So it looks, we have a couple. So the argument 2, or some argument immediately before, replace breakable with item drop. This looks like this e-breakable explosion types. And then e-init breakable. So let me start. adding those. So we want symbols. This is US BO RBO3. There's a couple ways to do this. I like doing it this way. I'm sure other people prefer doing it another way. So when there's new overlays and there's symbols that need to match code that exists, you could go through and kind of big bang pull in all of the data definitions for those while you're pulling in the code as well. What I found while doing this previously is that when there's often more things that get brought in when you're importing that data than just the immediate dependencies. And so then those are going to want additional symbol definitions, and you need to pull those in as well. And you just kind of keep going and going and going. And by the time you have defined the symbols that you wanted, it would have been faster, at least this, again, this is my personal experience. It would have been faster to just have gone through and mapped a certain set of symbols, imported that code, and then kind of rinse and repeat until everything is brought in. All the shared stuff is brought in. And then you can go back. Once you're building code as opposed to extracting and building imported assembly, you don't have to worry as much about the symbols and what their offsets are, because those things just work out with the compiler and the assembler and the linker. So I'm going to try to gracefully pull these out. So I'm going to look for everything that starts with D_US in this file, and I'm going to use sed to basically get rid of everything before. So I'm start anchor, everything, and then I'm going to look for an open parentheses because that is how these addresses are loaded. I'm going to get rid of all that stuff, and then I'm going to get rid of everything after the close parentheses to the end of the line. S is the substitute command, and then a slash. You can use actually several different characters to delimit the different fields, but the first argument to substitute is a regular expression, and then the second is what you want to replace that with. So we get these ats. I'm not too worried about that. That has to do with how greedy the match is, if you're familiar with regular expressions. I'll just ignore those though. So I'm gonna sort and just grab these offsets. So these are the 6 that we'll need to define to pull this in. And so one by one, we just kind of have to go through and figure out what those addresses are. All right, so let's start with the 414. Okay, so 414 is right after this replaceable, or replace breakable with item drop and being passed to initialize entity. So this looks like ginit breakable. Some of these might be wrong, and we can fix that. I like to go quick rather than be super accurate. This 5AO is right before animate entity. So it's probably this breakable animations. All right, so this one, do we have anything? So it's after this initialized entity. So we need to figure out which of these it is. It's looks like it's going to be breakable hitboxes, but let me double check that. Yeah, I think it's breakable hitboxes. So we map all these symbols, and then we'll re-extract the assembly, and we should see all those symbols in the places that we expect with the correct names. So this is right after create entity from current entity. So breakable explosion types. Actually, before I went on break, I did some work to the way our dedupe tool works, or duplicates tool works, is that it looks at all the operations in a function and then does a Levenshtein distance to determine what functions are similar to one another. There's a couple, so Sozu wrote the tool. There's another tool called CodeDog that I spent a little bit of time looking at that does something similar, except it just looks at the function binary in the ELF file and does comparisons there. So the two approaches have both have drawbacks. If you're just looking at the operation in MIPS, and maybe I have this up somewhere. No, I don't have it up somewhere. I did have this as a picture at one point, but okay. So when you look at the set of MIPS instructions and how a MIPS instruction is coded, let me pull it up actually, because it's kind of interesting, I think. The first 6 bits of the instruction define an operation, and then you have 20 bits of data, and then the last 6 bits are either more information about that operation, or it's added to the data and just part of the data in that operation. But many of the arithmetic operations especially all have the same opcode, the same first 6 bits. And so when you're looking at similarities between them, if you just look at those first 6 bits, let's see if I can find a good way to... This is the image I want. Ah, too big. So this is the set of opcodes. Let me make this smaller. So our dupes tool looks at the first 6 bits to determine what the operation is. Add, subtract unsigned, multiply, divide, etc., 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 and or they all have the opcode of 0. So regardless of which instruction that is, that opcode is identical. And then it uses these last 6 bits to determine which mathematical function. And so basically what this is doing is saying, if the first 6 bits are 0, send it to the arithmetic unit of the processor, and don't do any more. Don't worry about it. Whereas something like add immediate is not handled there because it has to decode more of the instruction to determine what the value there is. These are just operating on registers. Otherwise, the different components and arguments to that function are all registers. Source register. What's the second? Basically, the 2 operands and the destination. And then there's a fourth 5 bits that don't need to be used. So when our dupe tool comes in, it's building a list of what all of the operations are. And it's going to get some false positives because of how many operations are basically just defined as ALU operations that all have the same opcode. CodeDog, on the other hand, has the opposite problem because it's looking just at instructions. And so any instructions that have addresses or offsets that are I guess address dependent, those are all going to be mismatches, even though if we have a symbolic representation, they would be the same. So what I was working on in our dupe tool is going back to the assembly representation, and where we have things like this, where the symbol is unique for this particular overlay because of the address that's unique for this overlay, or in this case, this is a map symbol, even though it looks like an overlay offset. Go through and find each of those unique symbols, and then give them a name that is going to be consistent regardless of what the location of this function is and what the location of the data that it's referencing is, and then do the difference between the 2 functions. And when you find a match in that way, the benefit is you're able to do it regardless of what those symbols were called or what their offsets were, or the function names in certain cases. But if you have a known good version of that, you're able to find the new symbol names and do that conversion immediately as well. So I'm hoping to finish off some of that work in the next couple of weeks, and then my hope is that when things are being extracted, if you find that, in this case, the entity breakable function matches, because all of the instructions are the same regardless of what these offsets of globals are, we can find that match. But then not only that, but we can say, okay, we have all these generated offset variable names. We know what those are from a good version of that function, and we can generate all those symbols as well. I know that some of that is being done already, but I think we can do a little better, and our dedupe tool can be a little more accurate then as well. We do a bunch of things where I was showing the duplicates here before, where are these? The functions related to finding positional entities, find entity to the left, find entity to the right. We say that those are identical to one another because the difference between those functions is either iterating one direction through a list or iterating the other direction through a list. And so the only difference is addition or subtraction, which is good for when we first want to discover what functions are similar to one another. But now that we know that they're different, having them grouped all together makes things a little more difficult, I think. Opinions of one guy. Anyway, let's get back to this. So we have all these symbols mapped. Now what we need to do is re-extract, and I'm going to try to just do this by touching the yeah, I think this worked. Touching the splat config and then re-extracting, and yeah, now we have all these symbols in place, and so instead of the random offset names, the symbols are there. Great. So we still have these that are D underscore and then some symbol. These come from the original mapping of this. Let me see what this one is. This is right before, this is the argument to alloc entity. So it looks like this is, okay, this is G entities. It's not, this will map fine. I'm not worried about this one. So because we have the because we have all those symbols mapped, what was all that work for? What we should be able to do is replace entity, or replace this include ASM for entity breakable with the shared file, which is in the stage directory. Is it eBreakable? Yeah. And so let's try to do that and see how it goes. It might work, it might not. We'll see. So we just use the standard C preprocessor macro to do that. We're in a pretty deep boss directory, so we have to get out of RBO3, we have to get out of boss, and then we're going to go back down to stage and then include eBreakable. And if I mapped symbols well, this should work. Okay, so we have a few, we have some symbols that are not declared, which doesn't mean that we don't have the addresses for them. So let's look at the Maria cutscene. There's an eBreakable here. So there's a bunch of data that this expects to have defined. I'm not going to define it because that would require pulling in that data, which I don't want to do right now. This is the lazy way to import data, or to import code. So what I'm going to do is basically I'm just going to say that these are all externs, and we'll let the linker pull in the addresses from that. Yeah, I do think a lot of the shared stuff that we have in stage may be good to have in a. I've been thinking about some of the code structure that we have, or like the directory layout, there's some stub driver stuff in source PC. That is so different and uses a different build system even from the rest of the code, like having it in the source directory. To me, that doesn't make sense. The Saturn code is in there, kind of in its own directory. It's very different from the rest of the code. So I do think doing some work to separate game code from ports, or like an ARC type directory that a lot of projects use for architecture specific code. But then pulling a lot of this out into shared directory separately. I've mentioned it in Discord a bunch, but it would really be nice to have these as C files that could be brought in. There's some issues with Splat and the way Splat works that makes that not practical. Maybe a Splat is used by more projects that aren't N64 projects that just need one level of directories that and like one file that they're trying to rebuild that they'll consider some of those changes. So I need an E-explosion, and then I need to not import this. And it looks like is E-explosion. I want to see if that's okay. So this is an entity definition, and I don't know that we have any entity definitions for RBO3 yet, do we? No, so we need a RBO3 header file. So Biz Murphy's question: why would the functions be in overlays as opposed to just putting them in DRA where they would get loaded once? I guess memory constraints would be my best guess as well. It may have to do with how the project was set up originally as well. If you had, I haven't gone through the credits. That actually might be good to look at how many developers were working on this when they were building it. But it may have made sense depending on what their how they were working on the project at the time in a world before Git and using much more primitive like tools for sharing code. How were overlays built? How were when entities were updated, how is that new code brought in to a particular stage? I don't know. That's a good question. And it may actually have been related to how they wanted to debug as well. When this is built into an overlay, I can leave a room and come back and reload that file. And now I have my updated code, which is awesome. And I've been wanting to actually look into, I need to spend some time in either DuckStation or PCSX Redux. Because I do think that would be nice to make sure that when if you're just loading from a standard file system, can you reload that file fresh every time and make sure that it's not cached? All right, let's make sure we have the right entity explosion. Constant. So we create entity from current entity. And it's 0. I just want to make sure that this constant was correct before moving on. And now we have the ability to bring in our RBO3 header. Defined reference to... Oh, did I get rid of the wrong one? I did. I know you've spent more time looking at the Xbox 360 decomp. Or does it include, do you happen to know, does it include all of the duplicated functions for each of the stage overlays with different symbol names, or is there only one version of many of those? I would almost think that they would have to duplicate them, because there are cases where the overlay has a slightly different implementation, and how would they know? All right, so that worked. So what I'm going to do now, basically we just need to make sure all the symbols were mapped, and the macro, or the enum that was being used for the entity ID was being pulled in as well, and that's done. So what we can do now is use this to split this file in splat, and getting the overlays set up to have a consistent pattern will make bring in some of that duplicated code much easier. This is a pretty, if you're interested in contributing, this can actually be a pretty easy thing for somebody new to decompiling to do, because a lot of it's just bookkeeping. So what I'm going to do basically is go back and look at those splat configs and just start taking offsets for each of these functions, and then adding them to splat config to pull in code from different C files based on those offsets. So I'm going to go to splat US, and we can, I have a little bit of time, so I'm going to, I'll do a couple of these, and then we'll go back through and we'll decompile with something new. So we're not going to spend the entire time doing this. So we want boss RBO3. And I'm going to use the Maria one again, just as a reference. And so what I need here is, I need to figure out what the offset is, what name should we give this, and then kind of go down. And so the way that I'm going to do that initially is I'm just going to go through and find all the breakpoints between each of these. So this is eBreakable. My guess is that this is stdebug, but we need to see. Let's see, stdebug. Yeah, so there's two functions there. There is a cutscene with Medusa, so we can see if these are cutscene related. They might not be, though. So let's go through, and I'm going to ignore that for now, and go through and see if there's some other known symbols. Excuse the, the flashing. So here we have random and update. These likely are coming from stupdate. And I'll check that. Yep. And so that gets us through update stage entities. So then we have collision, and then this is create entity. A lot of those. It doesn't look like there's red door. Somewhere along the way. So I think that I'm trying to remember. Oh, there's red door. Okay. So this is where red door would start. And then stage common. So now we need to find the where collection starts. It looks like that may be around here. Blitchar. So the RO data being brought in here is this is something new that Zyanomo's tool did when bringing in new overlays, which I'm still not completely familiar with why it does this as opposed to kind of the implicit way that this was done previously. So our RO data is going to be strings, it's going to be jump tables for functions, and where that exists in this file is not terribly important, but the ordering of each of these includes is. The ordering of all of the includes in this file is important, but the include ASM versus include RO data, that's not important. I have to spend some more time understanding why the tool is doing it this way now instead of what normally happens with Splat is there's entries in the Splat config to bring in this RO data. Oh, that's interesting. So let's look at that. So Biz Murphy's saying that there was some RO data in his as a local variable, and so was that declared const, I'm guessing? We'll take a look at that. This is the yeah, I would be interested in seeing if making it const automatically puts it in the RO data section. But I guess it is already being in the way it's being compiled. It must be. Yeah, that's my guess. Is that I mean, ultimately, this is no different than how the compiler would treat a string. These are 16-bit values instead of 8-bit chars, but it's bigger than an immediate, so it can't just be encoded into an instruction. Yeah. So if you look at the global data, just making any of those const instead of just global read-write values will move it into RO data as well, regardless of what the type is. It just happens that static strings, the static declaration of it is immutable, so it can put it into RO data. Ultimately, I don't think that there's any memory protection on the PlayStation anyway, so it really doesn't matter, but I suppose the compiler doesn't know that. Good to know, though, that, yeah, that's it's always fun to find these new things. Also, something like entity warg. Where was this before? Some code that has existed for a long time. Well, no, this is different than the warg that exists in. Or no, is this just refactored? Sorry, looking at it the first time, trying to evaluate what it is. Oh, this hadn't been decompiled previously. I didn't realize that entity warg hadn't been decompiled. Awesome. Okay, let's go back. Let's keep going with this. So we're still trying to find where the different splits are. Blitchar. And then these, let me check if blitchar is one function or not. I don't remember offhand. Yeah, it is just the one. So now we need to find stage name, Latin, MISC. Okay, so room foreground and pop-up. Primitive helpers. Primitive helpers is here. Oh, we have all these as well. All right, so basically this is where the splits are for each of these. So what we can go through and do is look at this entity life up spawn, find what the address of the first instruction is here, and then add that to the splat config for this. And I'll go through that one for posterity. RBO3. So this splat config here is saying that we have a bunch of subsegments of different types. What I need here is what is the address for entity life up spawn. And it's going to be this 1EA44 value. So I put this here, and I would say that it's going to be a C file, and that I'm going to call it life up to match the others. And when I extract now, I can basically get rid of all of this. Splat will automatically create a new C file called e_life_up.c, and it'll include the ASM. I do need to tell it that I want this RO data as well, and so I will pull that value as well from this jump table. And basically, I'm going to say I want this in the same file. And this is actually somewhat nice to have this in place already. The dot before RO data says get it from the compiled object file, not data that's been extracted as assembly. I guess the advantage to doing it this way is that when that data is constructed as a jump table by the compiler, I don't have to make a change here at all. So I'm going to get rid of these here, and then I'm going to run an extract and build it again. I think this will work, and I should get a match as well as the new file there. Maybe I need to clean. I don't know why it didn't give me an... Oh, yeah, why didn't it give me a new extract? I don't know. When that happens, I clean and rebuild and go again and hope for the best. While that's going, let's find something else to decompile. I continue the same thing. It looks like it's not giving me those where I expect them. Let's see if it's extracting them. Oh, the directory that it pre-generated is incorrect. A symbol that seems unrelated is missing. I'll have to go back through and look at what might be causing that. But that's the general idea of how you'd start splitting these. Let me just check one more thing. No, it's not in this. I'm not sure why that symbol would change. Oh, maybe is that one of the new symbols that was mapped? No. Oh, so this was RO data unrelated to eLifeUp, so I need to not move that over. There we go. All right. So now eLifeUp is split. I'll go through later today and do the rest of those, and then they'll be each split into their own file then. And what I did earlier when I was working on the HD version of the center stage is I'll submit a PR for that, and then either I can go back through later and kind of incrementally include or set up the deduplication by including the shared code, or somebody else can. And I like to do smaller changes like that, where this can be used then by other people to continue doing work, as opposed to me just sitting on this for a couple days and kind of grinding through and mapping all the symbols and doing each of the all the necessary work for the entire overlay. All right, so while we're here and have 15 minutes or so left, let's find something new. So I'm going to look in RBO3, and we'll find something that hasn't... so one of the nice things about what we just did, though, is now we know that these first two functions are part of stdebug. These functions here are part of breakable, and the meat for this overlay is this set of functions here. So we have about six or seven remaining functions that are the Medusa boss. So relatively small. My guess is that some of these early ones may be more difficult. Let's actually do that, because I think that will kind of drive home where we need to focus, because we have we do have some functions that haven't received their symbols, not many. So we can just look at the FuncUS ones. I think that should be a pretty good proxy. We do have some that are probably duplicates, but we don't have to worry about those. So let's find files that are FuncUS. In RBO3. So we're looking for non-matching name FuncUS files that end in .s. And we want to grab the size and the name. So like I said, some of these are going to be duplicates, so we know that this is part of LifeUp. It just wasn't matched for whatever reason. So we can ignore that. Let's look at the range that so we want things between 1438 and 3050. So none of this. Here's 3050. It's relatively small. We could look at that one. So these are all fine. It looks like these here. This is 179C as well. This is likely the main state machine for Medusa. So let's pull the smallest. I said 3050. Oops. I'll see if my copy script is working today. It looks like it is. So we're going to go back to decomp.me and we'll start decompiling. We can check this against dupes. It's probably not the worst idea. It's not a duplicate. But it is relatively simple. Oh, I decompiled for PSP. Need to get a decomp that compiles for the first time. You don't see that too often. So not much. My guess is that the so we're going through primitives. This control statement for the do while is flipped. So I think we can flip that back. There's some unnecessary variables, but this one actually should be super easy. So let's see what is missing here. This is one of the best M2C decompiles that I've seen. Good job, M2C. I don't know if it's gotten better in the last couple of weeks or what. So we need to do a few things for cleanup. We have symbols mapped like this, GAPI_alloc primitives, because this is always going to be at the same address for the PlayStation, but we access it through a struct, which fixes up how it's loaded here. We're going to call temp v0 prim index and get rid of a bunch of stuff related to that. And var a0 we'll call prims, or prim. arg0 is self. And so now what I want to see is, for these remaining two, are they necessary? So this looks like it is the current index times 3e. Hey Fred, good to see people finding me on YouTube. So this looks like it is, do we need a separate variable for this? Probably at least an index. And so this could either be a multiply an index value by 3e, or it could just be a running counter that's that 3e gets added to each time. Either way is fine. So this is our x. I'm trying to think of what the Medusa animation looks like. Let's see if we can find that. This looks like something. The primitive is var v0. Okay, so this is just something moving across the screen. It's not stretching or anything like that. All right, so let's do this first. Let's change this to while primitive's not null, and move this out. And we're going to do this as the last step down here. That actually gets us a little further from complete match, but is more similar to what is typically there. This so we can move this var a2 down here and then use the value of it there without having to have a separate variable var v0. So we can just get rid of that entire thing here. One thing I want to look at, it doesn't make a difference. I was going to say we could change this to, if the step is not 0, return to reduce some of the nesting. That, based on that other change, that does get us a little closer. So, as Murphy's hinting at me that probably keeping an I value. So let's do that. Let's, I's are usually 16 bits. So we'll do, when you see in this particular code base, when there's a lower indexed point, or in this case, like the X component of that point, following a higher version, usually it's a single assignment like this. And so we'll do, go with that suggestion of I times 3e, do an I++, and then we're going to do the same thing down here, have that compound assignment, and do the same thing. And we'll see how that looks. So let's I'm going to go back to the way it was. Often when doing these multiplications like this, the compiler does identify that as additions. In this case, though, it doesn't seem to be. I will try one more thing. I'll move this down just to see if this is any better. No, it's not any better. So I'm going to go back to the way it was and see if that... so here we'll do var... it was var a2. The move implies that it's 32-bit. There we go. That was it. So there is, so we'll rename that because that's var a2 is not a nice name. We'll just call that X. We can get rid of our I. Should be, is it too gross to inline this? I usually don't like things too terse. Yeah, it's too gross for me. I'd rather have them on the same, or on separate lines, showing two different things. So let's see, there's some other cleanup we're going to do here, just to make that consistent. Hey, TimeFlex1, good to have you on the stream. Good to see people from YouTube. I had some fun with YouTube while I was gone. I had been playing... I play Ghosts from Nine Inch Nails in the background, which is Creative Commons licensed. I do want to start generating some revenue. So I can't play that anymore, unfortunately, because it's non-commercial. But I had a copyright strike against me on YouTube, and it wasn't that wasn't released under Interscope, I don't think. I think Nine Inch Nails was still with Interscope at the time. But it's a Creative Commons licensed, yeah, it would have been Interscope that they would have been signed to at the time. It's a Creative Commons licensed, though, album. And some Latin American record label claimed ownership and struck me. And so I had to... It's still in dispute, but... Oh, this was Null Corporation. So that, yeah, this was after they left Interscope. But yeah, not copywritten by a Latin music company. All right, so that's all we need for this. So we have an entity here. We should go through and figure out what this is. I will create a save point for Medusa either tonight or tomorrow morning, and then we can play through this section and see what we have. So I'm gonna replace the ASM placeholder here, and we'll see if this works, and it does. Great. So we have another one. So we have about 7 more functions here in this Medusa overlay that are unique to this overlay. And then Medusa will be done. I say it flippantly, the main state machine for Medusa, that's where the complexity is going to be these other, like, smaller entities from attacks and things like that. Those are going to be simple compared to the Medusa state machine. Hey Eldritch, good to have you back. Yeah, still going strong. I did a bunch of hiking, and now I'm back and sitting in front of a desk. Would I rather be hiking? I don't know. I know, yeah. I have been playing other game music in the background as well, and to this point, none of that's tripped. One of my early streams on Twitch, and I would like to get back to it, but it's not quite the same. I don't think there'd be as much interest necessarily. I was doing Sega CD, just playing through Sega CD games, and it didn't even occur to me. But I was playing Dune, and who is the soundtrack by? I can't. Where is it? It's up here somewhere. I can't think of who did the soundtrack for Dune. Anyway, it's very ambient background music. They play a clip from the movie at the beginning of the game, and Twitch caught it like right away. It was crazy. Oh, Toto. That's right. No, it was Toto that did the David Lynch Dune soundtrack. Vangelis was Blade Runner, which is also awesome soundtrack. So I got this copyright strike And yeah, it is a friendly one. Just like, oh, you can't put a highlight of this video up or whatever. Because you were playing Toto in the background. Toto. What Toto was I playing in the background? And it didn't even occur to me that that's who did the soundtrack for Doom. Or that part of their soundtrack made it to the Sega CD version of the game, which is awesome. All right, so you've been watching Made Up of Wires, and we've been decompiling Castlevania Symphony of the Night, and my decomp page isn't loading. I actually have. I mentioned this yesterday. I mentioned it earlier in the stream as well. I leave for a couple days, come back, and we had an internet outage here, and it has been flaky since. So I have a guy coming out tonight who should hopefully fix things, and maybe things will load when I expect them to. Today's stream went pretty well though. If you want to know more about decompiling Castlevania Symphony of the Night, go to soten.z.dev, and you'll see the progress on a lot of the different overlays and binaries that we've been working on. RBO3, which is the Medusa boss in the Reverse Castle, is not on this list yet. And so when I submit this change as well as the one from yesterday, I'll probably update the progress script as well to include RBO3 so we can start tracking that and see where we are. If you want to see this source code as well as other progress on the game, the source code that we went over for Biz Murphy's PR, there's a link at the top to go to the GitHub where you'll find all that stuff. You can find a link to Discord as well, where there's a bunch of people. I need to get back on Discord. I've been back for a couple days and haven't really looked at the channel, and probably should catch up with everybody and see how things are going. See if there's anything that I can work on. But that's it. Thanks for watching. Oh, no, I don't own this. TimeFlex, not my project. I just am a contributor. Zinamo is the founder of the project. He runs this site. He's in the Discord. And I just am here because I enjoy the project and enjoy the community. But that's it. That's all I got. I'll be back tomorrow. Same bat time, same bat channel. Adios.